Doppler velocity is accurately measured when each area is sampled twice. This is what the number 2 means in the Nyquist limit equation. In this diagram, the two purple waveforms represent two Doppler samples that display an accurate spectral velocity measurement on the screen. In this diagram, the smaller purple waveform represents a single Doppler sample. Since this area was only sampled once, the ultrasound machine fails to capture the true Doppler velocity and forces the waveform to wrap around on itself, thus reaching and surpassing the Nyquist limit. A real-life example of aliasing occurs when you're recording a helicopter taking off its launch pad. The rotor of the helicopter, which are the blades on top, spin in a counterclockwise fashion, while the propeller blades spin in a clockwise fashion. When you're recording it, at some point, the speed of the blades spinning will exceed what the frame rates on your camera can detect. So the rotor on the helicopter will begin to look like it's starting to change direction and spin clockwise, while the propeller will look like it's spinning counterclockwise. Another example is if you're looking at a two-hand analog clock in 15-minute intervals. Let's say the time is 3 o'clock, and after 15 minutes it's 3:15, 15 minutes from that is 3:30, and then 15 minutes from that is 3:45. Well, you know the minute hand on the clock is spinning in a clockwise fashion. If you're looking at that same clock in 45-minute intervals, let's say you start at 3 o'clock and you don't look at the time for another 45 minutes. Well, once 3:45 hits, well, not looking at the hour hand, you're just looking at the minute hand, your brain will trick you into thinking that the minute hand is moving counterclockwise. Now, coming back to the ultrasound world, this color bar scale lets us sonographers know how fast or the limit at which we can detect velocities. Let's say that the blood flow you're looking at is 60 centimeters per second, but your color bar scale is only set at 30 centimeters per second. Every velocity above 30 will be displayed on your Doppler as a bright, turbulent, high velocity flow. The best ways of eliminating aliasing include decreasing the pulse repetition period, or PRP, to increase the pulse repetition frequency, or PRF, and the Nyquist limit. Apply a low-frequency transducer to create a small Doppler shift for blood flow velocity. You can also try choosing a shallower sample volume, changing from a pulse wave to a continuous wave Doppler, increasing your Doppler angle, which then decreases the Doppler shift for a given flow, or adjust your baseline shift. Lower shifts are less likely to exceed the Nyquist limit and therefore less likely to alias.